All right, so we're going to be talking about graphing and how to graph and how to be able to interpret a graph. Okay, and so I'm going to break this up into two videos. So first, why do we graph? Well, it's just to summarize a lot of data into a picture and to show relationship between variables. Okay, so what is a variable? It's a detail about a situation that changes. All right, so in science, we can only work with variables that change in a way that can be measured. Okay, and so we're going to get into what exactly variables that we are going to be talking about. And there's two of them. So in your notes, I want you to go ahead and write this. We have independent and dependent variable. Okay, you have to think about variables changing. Some are causing the change, some are being changed. So an independent variable is the variable that influences another variable. Well, think about it. Your parents are independent and they influence you. Okay, so the second one is dependent. It's the variable that responds to the independent variable. Well, if your parents told you what to do, you're probably going to respond to what they tell you. Okay, so this is how I think about it. Think about the variables being independent and dependent. Which one sounds like it would be the influencer? Which one would sound like it's being influenced? So the independent is going to be the influencer, the dependent is being influenced. Okay. And so when we graph these, we have to always remember my independent goes on my x axis and my dependent always goes on my y axis. Okay. And so if you guys need to, go ahead and draw out a. So if you need to, this is my y axis. This is always my x axis. Okay. So practice. Miss Ebert wants to know if humor improves learning in period one. She makes zero jokes during her presentation about graphs and calculates the average quiz grade on that material. In period two, she makes 5 jokes. In period 7, she makes 18 jokes, then takes the average of their quiz scores and compares them to period one. Well, think about, what is she comparing? What is she trying to influence? And what is doing that influencing? And so if you look at it, well, she's trying to influence her quiz grade. So that's going to be my dependent. What she's using to influence it, so what's being my influence, is going to be the number of jokes in which she tells. Okay, so my independent variable is my number of jokes. And then my dependent variable is my quiz average, because my number of jokes is influencing my quiz average. Okay. So we're going to go ahead and skip a few of these. I want you guys to go ahead and try one on your notes. Okay, so you said, if you increase the time at which you accelerate at 2 meters per second squared, will the stopping distance change? Okay, so I want you to read through that again and try to determine what is being influenced and what's influencing. Well, if the time at which you accelerate at 2 meters per second squared, will the stopping distance change? Well, I already can tell I am comparing stopping distance to the time at which I accelerate. Okay? Now, it says underline the independent variable and circle the dependent variable. Well, if you read that again, my stopping distance is dependent on the time at which I accelerate. Okay? So my independent, it says underline the independent, so the time at which you accelerate is my independent, and my stopping distance is going to be my dependent. Okay? Now, in any science context, we have to have constants. All right. And so it's a detail in experiments that do not change. And the reason we have variables that don't change is so we know if we keep all the parameters the same around an experiment, whatever we're changing is causing the change of the dependent variable. So for example, okay, so if I were to grow tomatoes, Well, there's a lot of factors that go into growing a tomato. The light in which you use, the length of the light, the amount of water you use, the fertilizer we use, the grow medium or the soil that we use. And so we have to keep things constant because, say, I want to know how to make tomatoes grow bigger. Well, I have to change one factor to see if that change will cause my tomatoes to grow bigger. So if I change my amount of water I give on a weekly basis, everything else has to stay the same. So if my tomatoes grow bigger, I know that my change in water is the cause to that growth. But if I change my water and my light, and then let's say my tomatoes grow bigger, I now don't know which one is causing the change between my grow light and my water. Okay, so I have to make sure I have constants. Okay, in short, it's the only one variable that can change at a time. Okay, and the reason being, it's to determine that one variable is related to another. Okay, so we have three types of graphs. All right, and so the three types of graphs we're dealing with is pie graphs, and we use pie graphs to compare the whole data, okay, to a whole, okay, or part of a data to a whole. So percentages or fractions or surveys, polls, votes. So a couple examples. So if you need to, go ahead and pause this and write this down. Okay, so example, if I took a survey on your favorite pizza toppings, depending on how many pizza toppings I gave you, this pie would get broken up into, and in this case, we chose 4. All right. Also, we could talk about expenditures in school, okay, and how much money we have versus how much we delegate to certain things. An easy way to think of this is think about bills that your parents may have. Okay, how much money they bring in versus how much they delegate to certain bills. It could be 1,500 for the mortgage. It could be 400 for the car payment, 100 for car insurance, 100 for your phone bill. And so whatever they delegate that money to, we could break that up into expenditures. Okay. The second kind, and if you need to, go ahead and pause this, but the second type of graph is a bar graph. And this is going to be one that we use. And when we use a bar graph is when the data collected is a quantitative versus a qualitative. It's one that's a number, quantitative, and qualitative is something that describes something. All right, so it's not going to be a number. Okay, so it's good when we want to compare or visualize the amount of change that occurs. Okay, and so if you need to, real quick, go ahead and pause, finish writing this on your notes. So, for example, if we wanted to compare how many people and their favorite types of movies, all right, the qualitative would be the types of movies, the quantitative is the people that vote for these favorite types of movies. Another one would be coronavirus cases. All right. And so the quantitative is how many people got coronavirus, and then versus the date in which they got it. Okay. And so this could be day to day. So it's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And it's a 2-week process. And so it's comparing. It's good to see a comparison because right now we have a comparison between Michigan and Ohio being in the red and Michigan being in the blue. So it can help tell a good comparison between numbers and a qualitative data, which in this case would be a day-to-day basis. Now, my third type of graph is going to be a line graph, and we're actually going to be, the part 2 of this video is going to be how to draw a line graph. Okay, and so a line graph is when we have all data that is quantitative numbers. So your goal is to show a trend and pattern in that data, and this is going to be the most common graph that we're going to use in this class. Okay, just because we're going to be using 2 quantitative variables. So for example, the first one, we can compare the number of links and the number of hair with the time. Okay, so time being a quantitative data and the number of hair being a quantitative data as well. Okay, meaning it's something that we can count. The next one would be the time of the day versus the number of people in the store. And so we could see, and I would probably want to use this on a day-to-day basis because if I were to ever go shopping, I'm probably not going to want to go at 1 p.m. because it's packed. Okay. And so it gives us two quantitative datas, one being time, the second one being the number of people in the store. And so we can see it's a good way to analyze data when it's both quantitative. Okay. Now, we are going to be talking about relationships in line graphs. And so I want you to go ahead and draw this, and there's two on yours, and I want you to add a third one. It's a no relationship. Okay, but the first one is a direct relationship. And a direct means as when the x increases, the y increases. Okay, and so I'm going to go ahead and, so if my x increases, my y increases. So both variables increase. And so on the graph, we can see it. It's going to go up. It could be in a exponential growth or it could be in a linear growth. So I just want you guys seeing that they're both increasing from left to right. All right. And so you're going to see it in two different ways. So when I look at my X and Y data, we could see my X is increasing. So is my Y. Okay. And so this is what it's going to look like in the graph. This is what your variables would probably look like. On an indirect relationship, okay, it's going to decrease from left to right. Okay, and it also could be exponential decrease is what this curve slope is, or it could be a linear decrease. And so what you need to know is as my x increases, my y decreases, or if as my y decreases, my x increases. So you just need to remember as one variable goes up, the other variable goes down. All right. So as one variable goes up, the other variable goes down, and that's an indirect relationship. And then my last relationship is no relationship. And so the easy way to tell on a graph is that it's flat. There is no growth to it. Okay, so there's going to be no slope. Okay, so I want you to go ahead and go to part 2 of this video where we're going to talk about how to make a line graph.